Okay, so for question 2.3, we're asked, which of the following gates/circuits are not currently available in the Qiskit circuit library? So the easiest way to answer this question is to basically just go and try to import all of these different gates and see which one errors out. So let's just do from Qiskit dot circuit library import, and we can do H-gate, NAND gate, QFT, and quantum volume, right? And if we run that, we'll see that we get an error that says cannot import NAND from circuit library. So easy, that tells us that the answer to this question is option 2. But we should also try to think, why wouldn't there be a NAND gate? And the first thing that comes to mind is that a NAND gate is non-reversible, right? So if we take a look at, say, question 2.3, and we talk about a classical NAND gate. So let's just draw our NAND gate here with inputs A, B, let's call output C. So its truth table is A, B, C, and then we have 0, 0, 0, 1, 1, 0, 1, 1, and we get always 1 at the output unless both inputs are equal to 1. So the problem with this is that if we were to implement this directly into quantum hardware, well, the issue is that this gate is non-reversible, right? In quantum computation, we know that we need reversibility, so we would need some sort of, reverse gate. Let's call it, I don't know, NAND dagger, that when we apply it to this output would give us again A and B in the same way. But the issue is that since this is a single bit at the output, well, if we look at this truth table in reverse, well, 3 of our outputs are 1, so how do we know which A and B to select if now the input to this NAND dagger gate is 1? Now, that doesn't mean that we can't implement a reversible version of this, and in fact, a Toffoli gate is a quantum version of an AND gate. So if we were to implement this as a NAND gate, then all we need to do is we take inputs A and B, and now for the third qubit, which is where we're gonna send our output to, we have just to initialize that to 1. And if we implement the Toffoli gate like this and go through the logic of this circuit, well, we know that for a Toffoli gate, the target qubit gets flipped only if the control qubits are both 1 at the same time, right? So if we now do A, B, and let's call this output, let's call it C, which is equal to 1 at the input, right? We know that if these qubits are 0, 0, 0, 1, 1, 0, we know that this will not activate this X gate, so the output remains the same. So C remains at 1, 1, 1. But if A and B are both 1, then we flip C, which gives us 0. So part of the reason why there's not a NAND gate, an explicit NAND gate in the circuit library, is because you can just implement this using a Toffoli gate.